HPCC Systems presents HPCC for Managers. Lesson 11, the HPCC System Servers. In this lesson, we're going to look at our system servers definition, the process flow for typical queries on HPCC, the Dolly, Sasha, DFU, and the ECL servers, the ESP server framework, and the ESP-based tools that allow us to communicate back and forth with the cluster. System servers defined. The HPCC environment contains a number of system servers which act as a gateway between the clusters and the outside world. The system servers are often referred to collectively as the HPCC middleware, and they include the ECL compiler, which is an executable code generator and job server, otherwise known as the ECL-CC server. The system data store, which is the Dolly server. The archiving server, called Sasha. The distributed file utility, called DFU. And the intercomponent communication server, called the ESP server. Let's look at each one of these in detail. First, let's talk about the process flow for a query. Well, number one, the programmer writes the query in ECL and submits it. The work unit is submitted to the middleware via SOAP. SOAP is Simple Object Access Protocol. Number three, the Dolly System Data Store creates a work unit containing the query information. It communicates with the ECL server, which informs the ECL server to compile the query into native executable code and passes the work unit and the executable code to our ECL agent. Number five, the ECL agent executes the query, submitting portions to Thor as required, and Thor and the ECL agent update the work unit to reflect the results of the query and other statistics related to the execution, for example, graphs and timings. Next, the client interface is notified that the work unit is complete and that the results can be displayed to the user. Communication between the client interface and the rest of the system is all done via the SOAP interface to ESP. Communication within the system is done by updating the work unit and internal messaging and queues. So here's the servers behind the scene of the crime, if you will. Dolly is known as the System Data Store. It manages work unit records, the logical file directory, shared object services, and is also used outside of the environment to configure the environment, maintain message queues that drive job execution and scheduling, and enforce the LDAP security restrictions for data file scopes and work unit scopes. Now, Sasha is a companion housekeeping server to the Dolly server. And we had one of our close friends and dear colleagues a couple of years ago who passed away. His name was Nigel Hicks. He was the architect and basically the designer of Dolly and Sasha. And he named the servers after his two pet chinchillas. So Dolly, again, did not like to operate alone. He created Sasha as a companion to Dolly. Again, Dolly and Sasha works independently of all the other components of HPCC. It allows a restart to happen at any time without interfering with jobs already in flight. And Sasha's main function is to reduce the stress on the Dolly server whenever possible. Sasha also archives work units, which are stored in a series of folders and can be restored. They can also be manually moved to an alternate or off-site location. Sasha also reduces the resource utilization on Dolly, and finally, it removes cached work units and DFU recovery files. Now, DFU, or Distributed File Utility, is a special server that controls the spraying and despraying operations used to move data onto and out of Thor. DFU services are available from several sources. The ECL IDE, using service libraries in ECL code. ECL Watch, which we demonstrated in a previous lesson. And finally, the DFU command line interface, also discussed in a previous lesson. The ECL server, also called the ECLCC server, is a code generator and compiler that translates ECL code. When work units are submitted for execution on Thor, they are first converted to executable code by the ECL server. For Roxy, this process is done at deployment time so that a query can be compiled only once, but then executed multiple times. The ECL compiler server also is used when the ECL IDE requests a syntax check, uses a queue in order to convert work units one at a time, and however, there may be multiple ECL servers deployed in the system to increase your throughput, and they will automatically load balance as required. The ECL server compiler is also responsible for starting the ECL agent process to execute work units that target Thor or the ECL agent, or HTHOR. Now, our last system server is called the ESP server. This is also known as the Enterprise Service Platform and is the Intercomponent Communication Server. It provides a framework that allows multiple services to be plugged in to provide various types of functionality to client applications via multiple protocols. Examples of services that are plugged into the ESP include the ECL Playground, which provides an interface to query and manipulate ECL code. WSECL, or Web Services ECL, provides an interface to either an ECL definition or a deployed query on a Roxy cluster. The ECL Watch is a web-based query execution, monitoring, and file management interface. It can be accessed via the ECL IDE or your favorite web browser. Now, examples of protocols supported by the ESP server framework include HTTP, Hypertext Transfer Protocol, SOAP, Simple Object Access Protocol, JSON, JavaScript Object Notation, and finally REST, Representational State Transfer. Now, there are a number of ESP services that are used to provide a browser-based set of tools for managing your HPCC cluster, including my favorite, the ECL Watch, which allows you to do many things. Here are some of them. Well, you can look at information about active work units. You can monitor the cluster activity to see if how memory is being used, CPU usage, etc. Browse through previously submitted work units and see a visual representation of the data flow within the work unit using graphs, complete with statistics which are updated as the job progresses. You can also search through files and see information including record counts and layouts of each file, sample records, the status of all system servers, whether they are in the clusters or not, and finally, view log files. We can also start and stop any process in the ECL Watch. Another ESP-based tool, again, is called Web Services ECL, and this provides a web interface for controlling the deployment of queries to a Roxy cluster. Queries can be added, deleted, given aliases, suspended, and unsuspended or activated. It can also provide access to statistics about the queries that have been executed on a Roxy, including record counts and execution times. WSECL also controls the use of package files, which govern the mapping of logical file names on a Roxy. So you've now completed this lesson on system servers. You should now know that the system servers make up the middleware of LN's HPCC and what they are, the process flow for a typical query, and the purpose of each system server, including Dolly, Sasha, DFU, the ECL server or the ECL compiler, ESP framework. And you should know a little bit now about the ESP-based tools, including WSECL and the ECL Watch. So, this concludes our lesson on system servers. When you're ready, proceed to Lesson 12 and our last lesson in the HPCC for Managers series, HPCC Client Tools, and we'll conclude with a glossary of terms. Thanks again for watching.